Hello, everyone, and welcome to the Faculty of Engineering's Graduate Studies Ask Me Anything event for the Department of Civil and Environmental Engineering. My name is Sarah Landy, and I am the Manager of Graduate Operations within the Faculty of Engineering, and I will be your host for today's event. During today's event, we will be hearing from our faculty, current students, and admission experts from the Department of Civil and Environmental Engineering. We encourage you to use the Q&A button within your webinar screen to submit any questions that you may have about our graduate programs for our panelists. You can also upvote any questions you are particularly interested in hearing about. Within the chat, my colleagues Catherine and Jen will be answering questions you have as well. During the second half of the event, we will have a live Q&A session using questions that were pre-submitted as well as questions that are being asked in the Q&A chat. So let's get started. I'd like to hand it over to our panelists now. So please welcome our first presenter, Professor Ayn Pham.
Right, thank you very much, Sarah. Can you hear me?
Yes.
Okay, great. Hi, everyone. My name is Ayn Pham, and I'm professor in environmental engineering at the University of Waterloo. A bit about me, I got my bachelor in 2005, and then I started graduate studies, finished my master's in 2007, my PhD in 2012, and I joined the University of Waterloo as a faculty member a bit less than 2 years ago, January 2019. So I'm very happy to be here today to talk about, to represent my colleagues and to talk about some of the research activities that are happening in our department. I'll show you some of the cool pictures of our research facilities, and then I'll very briefly touch upon the graduate degrees that we offer in our department: Master of Applied Science, Master of Engineering, and PhD. But this topic will be covered in a greater detail later by our graduate admission coordinator, Victoria Tolton. Okay, so I suspect that some of you who are here today are currently enrolled in our undergraduate programs. So you may recognize some of the faces on this slide. These are the professors that you took courses with or are currently taking courses with. They are some of the many excellent teachers that we have in our department. What you may or may not know about these professors is that they are also excellent researchers. And in fact, in our department, we have about over 40 professors who are actively conducting research in addition to teaching. By that number, we are one of the largest, if not the largest department, civil environmental engineering department in Canada, at both the undergraduate and graduate levels. We are a big research enterprise. But we are big not just by the number, we are big by the research intensity and research quality. Many of our researchers are nationally and internationally famous because of their contributions to, for example, the advancements of engineering theory and practice. And actually some of the contributions can be outside of the area of engineering. For example, our professors are helping Transport Canada, Environment Canada, or Health Canada and other agencies with developing provincial and federal guidelines and policies. So again, professors are teachers and also active researchers. But what is interesting and exciting is that we don't conduct research all by ourselves. We do so with a team of masters and PhD students that we supervise. And quite often it's actually our students that lead the research program. And that's very exciting for the students, I think, because of the opportunities to work on projects that are multi-million dollars, multidiscipline. And many projects are actually in collaboration with governmental agencies and private sectors. So our students have many opportunities to work on real world problems, to learn different technical skill sets, to collaborate, to attend conferences and meetings. And so there are many opportunities to learn, to build professional network. And in that sense, it's very different. The graduate study is very different from the undergraduate study. Now, I told you that we have over 40 researchers in the department, so it's probably not a big surprise that we cover a wide range of research topics, from transportation to structure and materials to water and wastewater treatment, soil and groundwater remediation, construction management, building science. We are involved in even AI and machine learning, air quality, and biomedical. What I have here is just a partial list. There are many, many more that I don't have space to fit them all into this slide. Actually, also, I wanted to mention that the type of research that we do can be experimentally oriented, meaning that the graduate students will conduct experiments in the lab or in the field, but the research can also be modeling. And if that's the case, the students will develop codes, algorithms, softwares. And so, and some of the research can be a combination of modeling and lab work. So the key message that I was hoping to convey here is that there are a wide range of research topics for you to explore. And there are also different types of research that you can be involved depending on who you are and what you like. Okay, so one more thing I'd like to mention is that our research is made possible because of the truly cutting edge world-class infrastructure and equipment that we have in our department. We have lab scale prototypes. We even have pilot scale systems that are housed within the department. It is quite unique and unusual to have pilot scale systems housed at a university. So we are very fortunate for that. And our graduate students work in the lab, but also work in the field at field sites all over the world, across Canada, outside Canada. So here's some of the pictures that I have here of the instruments, the pilot scale treatment systems, and some of these images of the lab space that we have. And I'm going to, and here are the some more pictures. I'm going to hand this over to Professor Lacroix, who will talk more about these lab spaces and the experiments that are ongoing.
Thank you. My name is Daniel Lacroix. I'm an assistant professor in the civil engineering department. I joined Waterloo in September 2018 after completing my undergrad, master's, and PhD at the University of Ottawa. Then I moved down the canal and I did a postdoc at Carleton University. So I'm fairly new to the University of Waterloo, but I've been here almost 2.5 years now. My expertise is hazard mitigation of timber structures subjected to extreme loading, in particular earthquakes and seismic. Therefore, my research is highly experimental. So the picture to the left here, we have a test frame in which we are testing some timber specimens retrofitted with fiber reinforced polymers. So this is one type of project that we can do. The specimens are somewhat limited scale, but the main structures laboratory is a large space. And as you can see at the top right, we at one point had an experimental study on a full-scale 23-meter aluminum bridge. So it was tested for vibration in particular. So as you're walking down a bridge, you can feel the bridge moving. So it's all about perception. But the perception that you have on your own is not the same as when there is a group of people walking on it. So it was tested for all scenarios here. We also conduct some flexural tests. We have a wide variety of equipment. Here we can see groups of students in a graduate course actually investigating the effect of different retrofit configuration on the flexural behavior of reinforced concrete beams. So even our hands-on approach carries over into some of the grad courses where you have a lab component. So this is the research that's conducted within the university. But on the next slide, we have a lot of activities. So some of our researchers, for example, here we have a field site at a Canadian Force Base. We have a student surveying a river in the middle of winter. Then we moved to robotics. We talked about AI before. Professor Sriram Narasimham is actually a leading researcher in that area. And what he uses is robotics to actually detect damage in our infrastructure. This is to eliminate the bias that we have, us as humans, in terms of evaluating damage. And then the three bottom slides show graduate students that are actually on construction sites. For example, they're doing some quality control and sampling for concrete pavement, quality control for aggregate, and then finally just for regular asphalt. So as a graduate student, as Professor Pham mentioned, you may be highly experimental. It may be a combination of experimental and analytical, but depending on the type of research you conduct, you can find yourself in various fields.
Okay, great. Thank you, Professor Lacroix. So as you can see that our students, graduate students, are heavily involved in the research programs, and quite often they lead them. So, and so how do you get involved in this? We have 3 graduate programs that we offer in our department. The first one is Master of Engineering, but this degree is more courses oriented. So typical length is 16 months. The students take 8 courses. If you want to be involved in the research, in the activities that we talked about in the previous slides, then Master of Applied Science is the degree that you would want to consider, because in the Master of Applied Science program, students typically take 4 courses, and then the remaining of their time is devoted for research activities. And the typical length of Master of Applied Science program is around 24 months. And then after MASC, if you would like to continue to stay on and to do more research, Doctor of Philosophy or PhD is the degree after MASC that we offer in our department. Again, more on this will be covered by Victoria Tolton later. Okay, so now I'm going to pass this on to our current PhD and master students in our program, and they will talk about their experience and their research activities. The first student I'd like to invite is Helen Chow.
Hi, everyone. My name is Helene, and I'm a 4th year PhD student in the Department of Civil and Environmental Engineering, particularly in the water program. And my research, as it's titled here, involves the investigation of the use of electrocoagulation for the treatment of contaminated waters, specifically oil sands produced water. So what can I tell you guys today? Well, I was in your shoes at some point, and in my undergrad, I had a whole list of things that I could choose from. Should I go to work? If I do, should I go private? Should I go public? And what's this grad school thing that I keep hearing about? Well, that's where my supervisor, Professor Pham here, came in. I had the pleasure of working with him in my final year of undergrad for my 4th year project, and he approached me about doing a master's. And then 4 years later, here I am. I've continued to work on the same project and have transferred my master's into a PhD. So what can I kind of transition you into grad studies about? Well, I can speak to the big change it is, particularly in the amount of independence you have. I know some of you can probably relate, but I barely had time to think in undergrad. I was working on assignments, I was studying for midterms, I was writing lab reports. I was just following the strict rules that you had to follow in undergrad. Well, that all changes in grad school. Basically, your time is up to you. You can pick what you want to do, your research, when you want to do it, lab work, field work, stuff on the computer. And that can be both very exciting, but also very daunting. And the same thing is going to apply to your work schedule. It's very flexible now. Most people do the standard 40-hour work week, but others can work much more. Some can work less. Some work 9 to 5, some work noon to 9. There's a lot of freedom there. And during all this time, you're figuring out your research plan, you're conducting research, you're writing, you're reading. Some of you might TA. Some of you might be taking classes at the time. So my number one advice, if for anyone considering grad school, is to really flex those time management skills, because that's what's really going to get you through this. I know I might have scared you a little bit with everything I've just listed there, but I also want to say that you shouldn't be worried, because along with all this freedom, you do get a supervisor who is there to guide you through this whole process. It'll depend on your supervisor's teaching style, but overall, your supervisor is there to guide you through the maze, which is research, which can be quite scary. Even if they're not always around, some of our professors, of course, are very busy. We always can keep in mind that we're part of this large network of grad students, both in the larger community of the Waterloo campus and within your own research group. Right now, I guess we'll kind of keep it in context for COVID. I know a lot of us will be working remotely, but even then, I've found ways to connect with the grad community and other students in my department, which makes working remote less isolating than perhaps a lot of people are feeling. You can also join many groups, as I'm a part of SWIGS, which is for the Water Institute, CE2GA, which is for our department specifically, and the GSA. And all of these people and all of these groups are really looking forward to reaching out to people and making the community still feel like a community during these times. I can also speak to being back on campus and doing lab work, which I can personally say I feel safe, and it's been a really great experience so far. So I'm looking forward to answering any of the questions you guys might have.
Thank you, Helene. That was an excellent introduction to graduate school life. And then we have Maxime Lecroix, if I pronounced that last name correctly.
Hi. So yeah, my name is Max, and I'm a first-year MASC student in civil engineering at Waterloo. My research is focused on resilient timber connections using shape memory alloy dowels. So I chose to do graduate studies because of the advantages I think it'll give me out in the workplace. So I did my undergrad at Waterloo. And so through a few co-ops in different consulting firms in the Toronto area, I found that a lot of the people I was meeting that were willing or able to take on more responsibility had done some kind of research grad school, so MASc or PhD. So that's what got me interested in that in the first place. So once I kind of had that interest, I reached out to some professors that had, well, my interest was in timber buildings. So I reached out to some professors, well, Dr. Lecroix in undergrad and did some undergraduate research. So this was a good way to kind of meet professors and get a taste for research. So following that, that's kind of the reason why I chose the MASc program at Waterloo. I had already made some connections and also had a general topic of timber buildings that really interested me. So what I'd say for anyone kind of considering graduate studies, maybe a master's, if you're in your undergrad, I would consider strongly finding professors that have kind of similar interests as you and reaching out to them. Maybe you can start by doing a smaller project or something like that to really get a taste for research. But you don't have to, I was initially intimidated by the fact that I thought I had to come up with a topic and show up prepared with the topic, but kind of the process I had was just finding a professor who had the same interests as me and talking about it with them. And then a lot of my first 4 months in the program has been reading literature and really hammering out the details of what I wanted to work on.
Great, thank you very much, Max. That was an excellent discussion about how to find a research topic or how to find a professor who can potentially act as your supervisor. And that's what we wanted to talk about next. We wanted to talk about the research process and also other aspects of, for example, finding advisors, how that works. And then we will talk about admission. So as you may have realized that the general theme or the general topic that has come up quite often in what we have been talking so far is the research. So the difference between undergraduate studies and graduate studies is that in undergraduate studies, you take courses, write exams, and voila, here is your degree. Whereas at the graduate level, you take some courses, but most of the time it's going to be the research, and the research is the central it will be the center of the degree, right? So what is research? So essentially, research is to find something that is new and useful. That's it, right? So, and I wanted to emphasize that it has to be new and useful. It can be new but not useful and vice versa. But research, academic research, graduate school research is the search for something that is new and useful. And I can give you an example of things that are new and not useful. For example, this picture here up here showing a cat in a box or in a container. And what is it? It's actually a very interesting picture because a few years ago, I think it's 3-4 years ago, a team of physicists won a Nobel Prize for this research, trying to prove that a cat can be a liquid and solid at the same time. But that's not the type of Nobel Prize that you would want to win. It's an Ig Nobel, so for crazy ideas. And so this is new, right? Who knows that cat can be a liquid or solid at the same time? But is it useful? Well, it's maybe useful for the cat, but not for us. Right? So this is an example of something that is new and useful. On the other hand, the picture down here is an image of a material. It's a carbon nanotube. And for this product or this material, the people who invented this material got a real Nobel Prize sometime in 2000, early 2000. And the reason why they got Nobel Prize for this material is because not only the material is very interesting, but also this material is being used in all kinds of applications. Right? So, so research, you have to find for something that is really new material and useful, a material that can be used in all kinds of applications. So how do you go about finding something new and useful? So the process of doing research is very straightforward. You find the topics or research questions or ideas that you want to answer. And then you have to conduct review, literature review. You read a lot to determine if the research questions that you want to answer are actually new or not. Have other people done this, right? And then after reviewing the literature, you fine-tune the research questions and then design the experiment to test the hypothesis, to conduct experiment to find the answer for the research questions that you have. And you conduct experiments, you get some data, you have to analyze the data. And finally, if you find something new, then you have to communicate the novel findings at conferences or publish papers. Pretty straightforward, huh? Actually, it's not that straightforward. It doesn't go linear this way. Sometime after reviewing literature, you may have realized that the questions that you want to answer have already been answered. Somebody already has done that. So then you have to read the papers, read the textbook again, and think about new research questions, new hypotheses, and then going into the lab or conducting experiment in the field or writing some codes in front of the computer, designing the experiment, and then conducting the experiment. And quite often experiments do not work the way they should work, or the way you hope that they will work. You have to fine tune the experiment or redesign the experiment so that you can get some data. And then if you get data, you analyze the data and see that, oh, this is nothing new, nothing special about the set of data that I just collected. And then you have to go back and redesign the experiment and conduct the experiment again. So it's a repetitive process. But throughout this process, students often gain lots of skills, for example, critical reading, critical writing, communication skills. You go to to conferences to present the work or write papers. So you have communication skills, troubleshooting, and perseverance. So those are all the valuable skill sets that can be learned out of conducting research. And those are the skill sets that are very different from the skill set that you would gain when solving problems or assignments when you take courses. Okay, and then I will pass it on further to Professor Lacroix, who will talk about other aspects of graduate studies and research.
Thank you. So yeah, I would say I agree. Here it is depicted as a linear process, but often we circle back and we refine. Doing research is really your way of leaving a trace or creating an impact in the scientific community, that when you go and whether you continue into academia or you find another job, that impact will still be there years away, and other students or other researchers will be citing your work. So I think this is a really interesting idea that really drew me towards research in the first place when doing my master's, as opposed to just doing an MEng. And when you're doing this research, there is, as Helene and Max pointed out, you find out a lot about yourself, because doing the undergrad degree is really straightforward. You get up, you show up to class, you listen to the content, you get an assignment, midterms, and you go through, and then you get your degree. But here, there's a lot more independence. You have to, first of all, conduct a literature review. So how do you start about this? And then you really find, I guess, a topic, and then you contribute to the overall knowledge. This process, again, will differ depending on the professor, but usually professors, it's an ongoing discussion. It's not something that you'll do on your own. You'll have discussion with the supervisor, and we go back and forth until we find a project that both suit the student and the supervisor, and that can contribute to the research. I think one of the key as well as research, as a grad student, is yes, there is the research, but there's also the opportunity to mentor students, whether through TA-ship. There are some groups that you can join. For example, one of the groups that I am part of is Warrior Home. So undergrad students are designing a house for a solar decathlon, the competition in the States. And sometimes we have grad students who have certain expertise in that, and they get involved and they help the undergrad students. So yes, you have research courses, but you also have a lot of opportunities to have a social life or make a difference in other students' undergraduate degree or graduate research. So yeah, so that's what I have to say for this point.
Right, thank you very much. And now I'd like to invite Victoria Tolton, our graduate studies coordinator, who will be talking about admission information.
Hi everyone, can you hear me okay? Okay, great. So my name is Victoria Tolton. I'm the graduate studies coordinator in our department. And I've been in the role since 2013, I guess, is when I came in. Prior to that, I did my undergraduate degree and a master's degree at UW, followed by a master's degree overseas. So while I'm not an engineer, I don't have an engineering background, I do very much relate to the graduate student experience. So I always really enjoy that engagement with other students throughout the life cycle of the application and degree process. Next slide, please. Okay, so I'll go over a couple of the key differences between the Master of Applied Science and the Master of Engineering. I think there's a couple more points on this slide, Ayn, if you want to click down so that the full, yeah, they're all the way to the bottom, I think it goes. Perfect. So for the Master of Applied Science, as you can see here, it is a 24-month program, as Ayn has already mentioned. The Masters of Engineering, we do say that it is a 16-month program, but it can actually be completed in 12 if you choose to fast track. The Master of Applied Science is comprised of 4 courses plus a thesis, as well as some other kind of milestones that you complete during your degree program, whereas the Master of Engineering is purely course-based. So you come, you take your courses, and when your courses are done, that is when you would graduate. For the Master of Applied Science, you do have an academic supervisor or a mentor, and as has already been touched upon, these supervisors usually have their own little research teams of sorts. So whatever supervisor you come in and work with, you will likely become acquainted with the other graduate students working with that supervisor. The Master of Engineering program, however, you don't have a supervisor. It's purely self-directed. Master of Applied Science focused on problem solving, innovation, advanced knowledge, all these things we've been discussing so far. Whereas for the Master of Engineering, more of a focus on professional development. A lot of times we see people coming into the program who've maybe been out in industry for a couple of years and they would like to kind of brush up their skills a little bit, learn a bit more about what's going on, more cutting edge research, if you will. For the Master of Applied Science, it's a nice segue directly to the PhD. Whereas with the Master of Engineering, we generally do not admit students who have completed the MEng degree directly into the PhD. And this is because, as you can imagine, the PhD carries quite a heavy focus on research and problem solving and innovation. And without having gotten exposed to that at the MASc level, it may not necessarily allow for a super successful PhD experience. So if you're thinking PhD, you would need to complete the MASc first. And then lastly, for the MASc, you get paid to do your degree versus the MEng, where you yourself pay tuition. We do not have funding available for this program. Next slide, please. Okay, so as you can see here, we're talking now about the MASc program specifically, because as we already mentioned, the MEng program does not have any funding with it. So MASc students in our department receive $18,000 per year for 2 years, and this money is tax-free. And then you can see there the differences in the tuition costs. So for domestic students, you're looking at about $3,000 per term over, we'll say 6 terms, because that's generally how long it takes to complete the program. Whereas international students are looking at closer to $7,500 per term. So you might be looking at that and saying, oh, well, you know, $18,000 a year is only $6,000 a term, and my tuition is actually more than the money that I'm getting paid. So one of the ways you can kind of help make up that difference is with what we call a teaching assistantship or a course assistantship. As you can see there, you can make up to, you know, $4,220 a term doing that. This is not something that we guarantee to all incoming research students. It is something that you can apply for as early as your 2nd term, so long as you have completed the necessary training that we offer in-house. That's called expectations. We run expectations twice per year. So as soon as you have completed that training, you could then go on and apply for a teaching assistantship or a course assistantship. Next slide, please. And then just a little bit more information about some major scholarship competitions that happen that you might be able to apply for. So if you have an average of at least 85% in the last 2 years of your undergraduate degree, we definitely recommend that you apply for NSERC. Unfortunately, international students are not eligible to apply for this. It's only for domestic students. And then the OGS QE2 competition, domestic and international students can apply for this one. Okay. And then the very first one you see up there, Faculty of Engineering Fellowships. These are not something that you would apply for, but you would be considered for automatically at the time of admission. So when I'm reviewing your application, because I'm the one who does that in the department, if your application does fulfill certain criteria, then you would automatically be given one of these fellowships. One of the things to keep in mind is if you are successful either with a fellowship or one of these major scholarship competitions, these funds are not given in addition to the $18,000 a year. So that $18,000 that we were previously discussing, if you were successful in one of these major competitions, that funding is gone. So it's just these values here. Okay, and if you are interested in those scholarship competitions, our Graduate Studies and Postdoctoral Affairs, which is GSPA, they have a very detailed timeline for all of these award competitions that you can look up on our UWaterloo website. Next slide, please. Okay, so this is just to sort of give you an idea. If you are in fact graduating in June 2021 and you're thinking about starting your MASC that fall, this kind of gives you an idea of timeline. So if you're wanting to apply for NSERC, you're wanting to apply for OGS, you'll see down there the NSERC application is coming up already in November for next fall. So if you're thinking of starting your master's in September 2021 and you want to apply for NSERC, you're actually doing it this fall. OGS application is not due till a little bit later. So the transcript ordering, as you can see on our little timeline, is actually due January 15th. And then on February 1st, the application for OGS is due, but also your general application for the degree program to our department is due that date as well. So you're applying to the scholarships, but you're also applying for admission to the degree program by February 1. We generally take about a 2-month window to review our applications. So you would likely hear by early to mid-April whether or not your application was successful. And then you would be starting next fall. Next slide, please. Just a little bit more information here. So if you're thinking, okay, I'm not quite ready to start for fall of 2021, you can kind of see ahead. For MASC in particular, we do admit all year round, so fall, winter, and spring. For the MEng program, at least at the moment, we are only admitting once per year. That, however, is going to be changing in the short term. So it may even be possible that by the time you're looking to apply, you could apply for MEng at any time of year, but you'll be able to look that up on the website at the time of your application. Next slide. And then lastly, okay, so what do you need to do to be admissible to our programs? Overall, we're looking for a 75% GPA, so across all years of your undergraduate study. If you aren't quite there, you're right on the line, but you do in fact have a noticeable improvement in your final year, so greater than 78%, you would be eligible for what's called probationary admission. For probationary admission in the MASC program, you would still receive funding in your probationary term. And all that means is in your first term, your probationary term, you would have to complete 2 courses in our department. You would need to receive a minimum of 78% in each of the 2 courses that you're taking. And then as long as you meet that requirement, your probationary status is lifted, and then you would continue on into the rest of your program. And those 2 courses that you would be taking during your probationary term do count towards your degree requirements. So it's not like you're taking 2 courses and then you still have to take 4 more after that. Okay, and then for the MEng program, same thing. If you do come into the program on probation and you take your 2 probationary courses in term 1, assuming you get that 78% in each of your probationary courses, those courses would count towards your overall 8-course degree requirement. I can't remember if there's any more slides on for me. That might be all. Oh, there we are. Okay, so there's, that's Professor Robert Gracie. He's our Associate Chair, Graduate Studies. He is sort of the, I guess you could say, unofficial supervisor of our MEng students. So I know we said earlier, oh, MEng students don't have a supervisor, but Professor Rob Gracie sort of ends up taking on that role for the MEng program. That's his contact information there. And there's me below with much shorter hair. My contact information is available there. As you can see, I am working remotely at present, so you will not find me in my office, but I am more than happy to answer emails during regular business hours at the email address listed there. I think that's all for me.
Thank you very much, Victoria. And I think now we have Q&A session.
Yes, so thank you very much to all of our panelists. We're now ready to begin our live Q&A session. As a reminder, continue to submit your questions using the Q&A button within your webinar screen and upvote any questions you are particularly interested in. For our first question, I'm going to direct to Victoria. Victoria, is the MEng program open to all undergraduate degree types? So do you admit people to the MEng program that don't necessarily have a degree in civil engineering as an undergrad?
So this is a possibility. It's something that we have to approach very much on an individual basis. If you have an engineering background, but not civil engineering specifically, you may be eligible for admission. If you do not have an engineering background, that's a little bit tougher to say. We do have an option that we sometimes utilize called a transitional admission, where we admit somebody to the program. It's similar to probation in the sense that we sort of say, here are a couple of courses we'd like you to take to kind of get you up to speed. And then as long as you are performing adequately in those courses, you would then continue on into the program.
Okay, wonderful. Thank you very much. Our next question I'll direct to Ayn and Daniel. If you might know the interest to this, we have a prospective applicant who's studying in the States, and they're wondering if there are any restrictions when it comes to conducting research based on immigration status.
So I'll try to answer that question. I think without thinking about COVID-19, I don't think that there is any restriction. With COVID-19 and visa for international students, I don't know how that will change. Maybe Victoria know the answer for the visa issue.
Sorry, can you repeat the question for the visa concern?
So the student is the prospective applicant is wondering if their immigration status impacts their ability to join a research-based program.
So as of right now, my understanding is that international students are not presently entering the country. a lot of it is being done remote for the current time. We are in the process of waiting on approval, basically to demonstrate to the government that we have a COVID readiness plan, at which point we may then be able to start inviting international students back into the country and back onto campus. But for a student studying in the United States, for example, if you were required to at least begin your studies remotely prior to this approval that we're waiting on, you would still be able to receive your funding from your supervisor while you are in the United States.
Okay, that's wonderful. Thank you very much. Okay, Victoria, I think our next question, I think you can also probably help us out with. If you are a new incoming PhD student, do you still have to do the training to apply for TA-ship? So assuming they've done a TA-ship previously in another institution, does this mean they can't do a TA-ship in the first term either?
My understanding is that everyone coming into the program needs to complete our in-house training. The exception for this would be if you had done a master's degree at UW and had already done expectations once, you would not then need to repeat the same training in your PhD. I think normally we advise, though, that students need to complete our specific in-house training.
Okay, great. Thank you very much. Our next question comes to our two student panelists. So maybe I'll ask the question and then Helene can start and Max can follow. What advice do you have for students that are currently looking to apply? Things you wish you knew before you applied, and things you would recommend them doing to get ready to make their application to grad school?
Well, that's great that you're thinking about that ahead of time, because that is something I should have done beforehand. Attending events like this are great. It does give you an idea of what to kind of expect in grad school. I think the number one thing is to try and find a supervisor whose work style and research topics align with what you want to do. And once you make a connection with that supervisor, to ask what kind of research are you working on, what kind of students are you looking for to do that research, and can I do any readings ahead of time? The first 4 months of grad studies is usually you just reading a bunch of papers about the topic that you're researching. So if you can get a head start on that, that will give you a huge boost. Specifically because we're going to be working from home, I think that's a great opportunity to get ahead on that kind of stuff. So that once you are able to get access to the university to do lab work or get a computer or whatever you need, you can just hit the ground running. But yeah, really developing that supervisor relationship is really important throughout your entire grad student career. So as soon as you can get talking to that person and develop a relationship, better.
Fabulous. Thank you. Max, did you want to add anything to that?
She covered most of it, but yeah, I guess what's really important is just finding something you're really passionate about if you're doing research, because it's really like what you're going to be spending most of your days doing when you're really only taking 4 courses, and you do them probably at the start of your degree, and then your research project kind of takes over your life. So I definitely just make sure you find a project you're passionate about.
Okay, wonderful. Thank you very much. Victoria, we have a couple of questions coming in about the PhD program. So is the first part of the question is the PhD program deadline, application deadline, the same as the MASC application deadline? And also, can you just highlight what kind of funding is available for domestic and international PhDs as well?
Sure. So the application deadline is the same. Sorry, I've got multiple windows open right here. The application deadline is the same, and I don't have access to any of my notes because I'm talking to you all outside of my VPN at the moment. We do also have a guaranteed funding package for our PhD students. I'm trying to remember, I can't think of the annual amount off the top of my head, but I'm going to give you the per term amount. So it's about $8,000 per term is the amount of funding that a PhD student receives. So $8,018, I think. So if you multiply that by 3, that's your annual amount. And then if you are an international student on top of that, you receive an additional amount on your funding, and I think that's in the neighborhood of about $14,000 per year in addition to the 8,000 per term.
Okay, wonderful. Thank you. Our next question I'm going to direct to our two faculty member panelists. Is there a way to know what professors are actively recruiting for MASC students? This particular individual is trying to connect with some faculty members over email, and they're having a hard time getting through, so that they're wondering maybe if you have any recommendations for how to attract the eye of a prospective supervisor. Ayn, if you want to start.
Okay, I'll start. So this is a win-win situation, right? The students want to find supervisors, but on the other hand, professors really need students to carry the work. So you need us as much as we need you. And we usually try to recruit students by, so if I teach a class, undergraduate class, I'll announce that, hey, I have a project that I need to find graduate students next year. So if you're interested in coming and talk to me, another way that I often do is I put up advertisement on my website saying that I have these positions for these projects. So one way to connect with professors or to find whether there are available projects that you can potentially work on is to visit professors' websites. So first of all, when you do that, you learn about the type of research that professor is doing anyway. And that is always a good idea because you want to find something that you are passionate about. And then you send an email to professors. And I think that usually professors will reply to emails requesting for available positions or information about projects. Maybe during this COVID time, email response are slow, but it's usually we reply to emails from students asking about graduate studies.
Daniel, did you want to add something to that?
Yes. So as, I guess, a professor, I have a website right now, and I do post whether I'm looking for graduate students or not. Again, COVID has impacted at least in my situation, because all the labs are closed right now. So it is a bit difficult for us to know what's going to happen, especially with the second wave. But one tip to get to professors, especially if you're not from University of Waterloo and you're an international student, actually making a decent effort of going to read the research interest. If you're really interested, try to make a statement or connect with the professor's research interests. I mean, in some cases, I get emails that are not even addressed to me. So in those instances, professors won't necessarily take the time to reply. However, I do reply to all emails that come in, and that the student do make an effort of connecting. And so try to have a more personalized approach, and be mindful of the grammar and the way you address the professors. It all affects how a faculty member might view the email. And also, please be patient with COVID. We're all receiving a lot of emails. Sometimes I take the Saturday of my time to review all applications or requests for applications. So I usually don't reply right away. So please be patient. Don't send, reminders within 24, 48 hours. Those are all little things that can affect whether a professor gets back to you or not.
Okay, great tips from both of you. Thank you very much. Victoria, our next question has to do with study permits. This prospective applicant is wondering if they have to apply for the study permit separately from their application to the program. Could you just highlight a little bit how a study permit would work for an international student who is applying?
Right, so the study permit application is completely separate from the online application that you complete to study with us. Admittedly, I don't have a ton of experience with study permits just because they're conducted differently depending on where you're applying from. We do have a really good resource through the University of Waterloo where there's a whole team of immigration specialists that you can connect with. Is there a way, Sarah, that we can get that these kinds of information out to people after the fact?
Absolutely, we can make the link to our immigration office
Yeah,
available.
I think that would probably be the best resource to make use of, and then you know that you're getting guidance from someone who's actually trained in immigration, because unfortunately the grad coordinators, we just don't have immigration training, so I wouldn't want to say something out of turn there.
Okay, excellent. Thank you very much. Ein, one of our prospective applicants is wondering if solid waste management is an area of research within the department.
Yeah, so solid waste management is a very broad field. Solid waste. So I'll give you an example. I don't do solid waste management, but I deal with solid waste that are contaminated with emerging contaminants. And so I don't manage in terms of writing policies or guidelines or suggesting ways to manage it, but I do research on how to remediate or clean up contaminated soils. So, and that's a solid waste management. So I don't know if that answers your question, but any area of research, let's say water treatment, under water treatment, you have many other small things. And then solid waste management, under solid waste management, there are many small subfields. And so we do have solid waste management research expertise in a broad sense, but we'd be happy to talk a bit more about it if you're interested in.
Excellent, thank you very much. Our next question, I'm gonna go back to our grad student panelists. I'll read the question, and then maybe this time we can start with Max and go on to Helene. This prospective applicant is in the process of identifying research areas that they're interested in and are interested in contacting prospective supervisors. They want to know how you narrowed your area of interest down to focus specifically on what you landed on working on, and how that led you to finding a faculty member that you continued your studies with. So Max, do you want to start?
Yeah, so for me, I was interested in mass timber, so that kind of narrowed it down quite a bit. But if you have multiple professors that do something you're interested in, I don't think there's any harm in reaching out to multiple professors and really seeing which one would be the better fit, or just kind of communicating with these professors. You might realize you're more interested in a certain topic rather than another. So yeah, like a lot of it, a lot of the work you'll be doing will be with this professor. So to make sure you have the right fit and also a topic that interests you is definitely important.
Great. Helene?
Yeah, so I guess I'm on the other end of the spectrum. When I started becoming interested in grad studies, I really had no idea what I was interested in. I knew broadly I wanted to do something involving water and water treatment. And that's kind of where this talking with your supervisors really helps. If you're already a Waterloo student, if you have that connection already with the professors, it's great to reach out to them and see what kind of projects they have. And perhaps, as I mentioned, you can check their websites to see the papers they've published and what research interests they have, and kind of Google around and see if that's something you might be interested in. At the end of the day, nothing that you, especially for a PhD, I know a lot of you are listening to masters, but you're going to become very niche in that topic. So it might not be exactly what you are interested in, but there's always interesting things that you can find no matter what topic you're doing. So it's really more important than the topic, I think, is the supervisor relationship. If you don't get along with your supervisor, it's not going to be an enjoyable experience, even if you're super passionate about the topic. And the other way around, if you have a great supervisor, you can find passion in the topic they can even just give to you. So that's more important, I think, making sure you have a good supervisor.
Yeah, great.
If I can chime in quickly here. So it's important that you like the project, the topic, but also it's important to think about the skill sets that you can learn out of the project. So sometimes the project may or may not exactly what you like, but you see the connection between projects and you see the skill sets that you can learn out of from that project. That is also very important.
Yeah, I'll add to that as well, actually, because this is a great question. I know when I was doing my master's project, what I originally wanted to work on ended up changing quite a bit from what I originally thought. So I would say it's not as important to get really hung up on what do I 100% like, because it's almost a guarantee that the nature of what you think you're going to do is going to totally, maybe not totally change, but change at least enough from what you initially started out doing that it will look different. So yeah, don't stress as much about like I have to find the thing, because you may just find if you start with broader strokes, whoever you end up working with will help you define that better and pull you in a direction you may not have originally anticipated.
Yeah, and I agree. I will go with a personal story here. When I applied for a master's back in September, I initially was going to do soil engineering, so completely different from structures. And then I met this professor during my capstone, and I just did a 180 shift, and I went to structural design. And then when it came time to select a topic, the professor said, well, I have this interesting topic that you mentioned, but I don't necessarily have funding, but I have funding on the other one. And who would have known that 12 years later, I'm still working in blast engineering related to mass timber structures. So I fully agree that think about the skill set you'll gain, the opportunities. And, you know, I enjoyed the topic. I still enjoy it. So I think you can learn to love something as long as it's within the area that you're envisioning.
Great, thank you very much, all of you. Those were great answers. Victoria, we have a prospective applicant wondering how competitive the MEng program is. They're specifically interested, they're applying from another Canadian institution, but they're wondering what sort of GPA, the minimum 75, but how competitive is the program?
So I would certainly say that all of our programs are competitive. We definitely pull more MEng students into the program than we would pull perhaps to our other disciplines like the Master of Applied Science or the PhD. So I would say if you do meet our minimum admission requirements and you are applying to the PhD program, your chances of being admitted are probably higher than they were one-to-one if you were also applying to the MASC. We really love bringing our own students, you know, back into the program. It's always great to have students from other Canadian institutions and get some interesting perspective on how some of these other engineering programs are working across the country. Yeah, so I would say if you meet the admission requirements for the MEng, your chances are probably decent of being admitted. That's about as much as I can say without being like, yeah, you're definitely going to get in, or no, you're not. But I would say if you meet the minimum requirements, yeah, it's more likely that you'd be admitted to MEng out of the gate than the MASC. And again, that's just because with the MASC, you need to have a supervisor, and we don't necessarily always have enough supervisors to bring in the amount of students who are applying.
Okay, absolutely, that's great. Thank you very much. I think we have time for one last question. I'm going to direct it to our two faculty panelists. Prospective applicant is wondering about connecting with former students of faculty members to sort of get a feel for the research group and how the faculty member works. How would a prospective applicant go about finding out who former students of a faculty member were? Ayn, do you want to start?
That's a great question. And that's actually what I often do when I was a graduate student. I try to connect. So I was looking for jobs and things like that, and research positions. And I always try to find alumni who graduated from a group to connect with those alumni and to ask them for their experience. So one way to do that is what I would do is I go to the professor's website and look at if there is no section on alumni who went through the group. I will look at the papers that that professor has published with the students, look up the student's name, and then do the search on Google. And most likely you'll find the person, and then send them an email and say, hey, I saw that you published this paper, you graduated from this group. I would like to talk to you a bit about your experience going to the grad school with that professor.
That's fantastic advice. Daniel, did you have anything to add to that?
Yeah, I mean, it just goes one step further. I mean, if you're interested in the research for that supervisor, at the same time, when you look a paper up, those papers are often co-authored with students. And when you're sending a paper in to get published, you have to provide author information. And often you'll find the student's email as part of the information. So by tracking down papers and reading them, just look out for authorship information, and you can probably get some their student's email. And I guess this is one perspective or one aspect that I'll consider in the future. I have an active student list, but I did not list their email. So that's a great point that you bring up.
Great, thank you both very much. Well, that wraps up our Ask Me Anything event for the Department of Civil and Environmental Engineering. If we did not get to your question, you can always send your questions directly to civegrad@uwaterloo.ca. Please make sure to visit the uwaterloo.ca/engineering/future graduate students website to stay up to date with upcoming events, admission information, and resources to help you with your application to graduate studies at Waterloo. Thank you so much for joining us, and we look forward to welcoming you to Waterloo Engineering Graduate Studies.